Okay, today topics talk is we're talking about the biochar for sustainable soil health in Southeast Asia. So for the introduction, we're talking about the soil health. Soil is a living natural resource that is the foundation of all healthy plants. It is vital to create and maintain soil health to maximize food production. So here I would like to share with you the definition of soil health. Soil health is the continued capacity of soil to function as a vital living system within the ecosystem and land use boundaries to sustain biological productivity, promote the quality of air and water environment, and maintain plant, animal, and human health. So the soil is very important to maintain our environment. At the same time, we can produce our crop and for the human health. So, but currently, so this one is the from the United Nations 4 years back. A third of Earth's fertile soil is being acutely degraded due to intensive farming as a global demand for the food grows. So this is a very serious issue that's declared by United Nations. A third of Earth's fertile soil is being acutely degraded. So sustainable soil management requires it balances the need for human purpose with those for environmental conservation and functioning. So how we want to do it that? So before that, I would like to introduce about the soil in Malaysia. So this is, as we know, we have 12 soil order in Malaysia, and this one is 4 of them with the soil or sea soil, soil, spore soil that we can found in Malaysia. So this why I would like to share this book produced by Department of Agriculture. More than 350 soil series are known to occur in the peninsula alone, and their profile have been described in the detail by the Department of Agriculture. That you can buy this book, this book with the Department of Agriculture that explain about the 350 soil series in Malaysia. So when we're talking about this type of soil in Malaysia, and Peninsula Malaysia itself, soil dominantly falls about 75% into the soil and soil order. So I hope in this kind of the soil and generally very acidic, have low cation exchange capacity or cation retention capacity, meaning that for the under this soil and soil is infertile soil. So we have another type of soil or the soil in Malaysia. We call it soil and spore soil. So soil is normally found near the sea and has a high sand content with a sandy texture. So we know that with the sand this sand is a low surface area and low charge, and hence does not attract and retain water or nutrient. So meaning that the form of the soil is infertile. So how to overcome the problem under soil sustainable soil management? We have this product, we call it biochar. So biochar from the farmers and also from the researchers said that this product is a promising approach to persistently improve soil health and promote crop growth. So before I go further about the biochar, I would like to share with you about the history of biochar. So biochar began during the pre-Columbian era, and it is associated with the terra preta soil, that soil of the Amazon basin region. So normally terra preta refer to the dark, very dark carbon-rich fertile soil found throughout the Amazon river basin. So this one claim that created by the farming communities made by human in 2,500 years ago and abandoned after invasion of European. So compared with the surrounding soil, because this one how that the scientists claim this one is man-made, because when we see this one cross-sectional profile 1 meter depth comparing terra preta, and then we call it that earth in Portuguese on the left, with nearby ocean soil on the right. So this soil is quite nearby. Then that's why they claim this one is the man-made of the soil. So compared with the surrounding soil, contain 3 times as much phosphorus and nitrogen, and contain far more carbon more than 70 times. So this is about the history of the biochar. Then this one is the location that our researcher found this terra preta soil in the Brazil, and you can see the map of the terra preta soil, and the deep deposit of black intensively fertile soil in the Amazon rainforest, which is found right alongside same at the infertile soil. This one. So you can see the red color is the terra preta soil, and the beside that is the infertile soil. Then this type of the soil order is oxysoil. So we know that oxysoil is infertile soil. Then in the under oxysoil soil in the Brazil, we can find this type of this soil, terra preta, man-made by human that time, 2000 years ago. So this one from the scientists believe it was created over 1000 years ago by the practice slash and char, not slash and burn. So you can Google about this term, slash and char, compared with the slash and burn, because when we slash and char, we can make it a pile of carbon in our topsoil. Compared to slash and burn, we release the carbon dioxide to the atmosphere. So this is the method, the belief how the terra preta develop soil dug out to create the hole. So the type of the soil like this, the dug of the soil, and then it placed back on the top of biomass, and the lot of this area set with the fires. So biomass in the top of the area, very high moisture content and lack of oxygen, made fires smolders for hours and even days. So when we talk about the smolders, is about the burn slowly with the smoke but no flame. This is they believe this is how the process to making the terra preta. So later on, later on the definition, to make it simple, we call it pyrolysis process. Pyrolysis process. So what I would like to share with you about the late of Prof. Wim Somborik, the champion the study of the Amazon dark soils. So they study a lot about this kind of the soil. So with his passion for the terra preta soil, the interest in creating terra preta, then which eventually was called Biochar. So this is the history, how that Biochar came out from the idea for the terra preta that man-made from the 500 years ago to 2000 that abandoned in the Brazil area. Then the scientists claim with we burn slowly of the soil that we can make it our soil to very fertile and a lot of carbon. So eventually we call it biochar. So this is a history about the biochar. So what is the pyrolysis currently to make it we understand what is biochar. So this is the definition of biochar, a carbon-rich material produced during pyrolysis process that is a thermochemical decomposition of biomass with a temperature about less than 700 degrees in the absence or limited supplies of oxygen. So this is process when we convert with the biomass with the absent or limited supply of oxygen. So the biomass, we talk about the agricultural waste. And for example, here we have empty fruit bunches, and we have animal waste and goat manure, and this one is from the forestry waste, wood chip. So this one is kind of the biomass that we can convert to the valuable product. We call it biochar. So this is the product. So along when we transform the pyrolysis process, we get biochar. The same time we can get another product within this process. We call it bio-oil and gases to produce, which can be used for the generating of energy and various chemicals. So this one is another product. So today we talk about biochar. Then this is another type of biochar that we can found in the Malaysia, bamboo biochar. And so we have the pyrolysis plant at Kedah and palm trunk biochar from my project from my student. Palm kernel biochar that we can you can get this one from the industry, also from the MPOB in Malaysia, and rice husk biochar, rice straw biochar. These are various of type biochar that we can have nowadays in Malaysia. So this is one figure. This figure I would like to share with you about how the pyrolysis system. This figure, you can get this figure under International Biochar Initiative and their website. Very nice diagram. We make it more understanding how to produce biochar. So we have the feedstock, or we call it biomass. production process utilized by cellulose. So we know that biomass contains cellulose. For example, manure, organic waste, bioenergy. So this one is the pyrolysis system, pyrolysis technology. Then this pyrolysis, just now I mentioned that along with the biochar product, you can have another product, bio-oil and hydrogen. So in this one, another product that we can use for the transport, energy, and the others for the chemical and for the industry. So this is one part where we want to discuss further about the biochar. So for the 100% carbon from the biomass, 50% goes to the another product biofood, and another 50%, around 50%, the return to the soil as a biochar. So this function of the biochar as a soil amendment. So the elemental composition and structural configuration of biochar is strongly correlated with the temperature, heating rates, and residence time maintained during its production. So this depends on this stage with the temperature, because just now the definition of biochar less than 700, and depend on your technology, how range of the temperature and the heating rates, and the process, is it fast pyrolysis or is it slow pyrolysis, and so on. So this is the process that you can more understanding, that you can get the figure under International Biochar Initiative. Then this is the annual product. So very nice color, blacks and so on. So we will make it, this product follow the pyrolysis definition, meaning limited and very limited or no oxygen, you can get this product quite very black. If you burn with the a lot of oxygen, your product can become ash. And so you want to make it slash or char or slash or burn. Then how to make a biochar? I would like to, because we go further about the utilization, how biochar make it our soil hub. So I want to introduce you how we want to make a biochar. So this is the example, the early char making, and this is one method. We just maybe this person want to try make it similar with the terra preta soil, but we can see here should be in the smaller stage, meaning that no fire. So this one quite environmental and unfriendly. Then the same time unfavorable method, but for this one, this is on the early char making. Then after that, in Malaysia we have a scientist come up with the technology. So we have lecturer in UniKR, Dr. Benjamin. So we upscale the technology with this kind of the gasifier method. Also we have another technology from our farmers. Then we have this method is adopted from the Japan by our agency, local agency in Malaysia, FOB and Universiti Malaysia. Then generally cost of production for this one is very low, but the quality of char varies because we cannot control the time and the temperature and so on. Then we need to enhance our technology to make it our biochar more quality. So we have another technology how to produce biochar. This one we call it microwave power pyrolysis. This one innovation by MPOB. So we have another method or technology using heath cell as a source of energy by MPOB. So we have another method, we call it microwave powers, UPM. So we can go to this MPOB and UPM to see by yourself about this technology. So for this big scale, pyrolysis plant power by fuel usually able to control the quality of product by controlling the process temperature and mixing time. So the keyword for the pyrolysis system is about temperature and mixing time. So how you want to optimize your time, and you want to optimum your temperature to get the good quality biochar. So we go to the further about the properties of biochar. So why biochar good for the soil health? Why biochar? We always highlight about the benefit of biochar for the soil health. So the properties of carbonized biomass depend on the feedstock. So you need to characterize of your properties, and then after that, after the pyrolysis, you need to characterize again. So different feedstock, different properties. For example, for the goat manure, high nitrogen compared to rice husk, low nitrogen. Of course, you can get the low nitrogen and high nitrogen after the pyrolysis. So depend on the feedstock. So a carbon-rich and porous materials is a very important characteristic of the biochar, can be used for the wide range of application. So you can see here the example of the porous after the process of pyrolysis with the lower and the higher temperature pyrolysis system. You can see the porosity open, the surface area of the biochar, that the products is more increased. For example, here rice husk for the degree 350 is we cannot see the porosity. So the 500 is quite okay, quite big. So 650 is quite more porosity size of the rice husk. So we can conclude that rice husk 650 is very good quality compared to another temperature. So we can use the high-end pyrolysis system technology. Then we setting 350 because from the initial study we can see that the result of the 350 we can get the quite large porosities of the biochar. So for the carbon-rich and porous material can be used for wide range of application because of this characteristic of biochar that can be used a wide range of application. For example, soil amendment, nutrient retention, carbon storage, pollution control, as a catalyst, as a microbial carrier. So after that, we go slide by slide about the every application. So biochar is a strong sorbent with very high affinity and capacity for sorbing inorganic and organic compound. The same time, the properties is the porosity quite big. At the same time, the properties is a strong sorbent with very high affinity. That's why the range of application quite huge here. Six application that we can use biochar for our soil. So this one is the benefit of the biochar. I'm so sorry because I put the figure here. This one I want to share with you. We claim that biochar can increase the pH. That then with the scientific report we can make it that's yes true. Because we already done the scientific research to proving that acid that biochar can increase the acid. So the around in Malaysia, so I think you already know about the pH in the Malaysia. So around 30% of the total land area in the world and more than 50% of the world potential arable area fall under acidic soil, including Malaysia. So you can find one article that published by Universiti Malaysia from previous study. From their study, they collected 241 samples. Then we did in Penang, Malaysia. Then maximum of the soil in Malaysia 7.01 and the minimum 3.04. So normally 3.04 undergoes acid sulfate soil. Then average for the Malaysian soil is 5.40. So 5.4 is the average for the Malaysian soil, and then we know that the optimum for the plant growth is average the between 5.5 to 7. So this one is a very important biochar, and we need so normally we add liming as to increase our pH, but biochar has a capability to increase the soil pH. So application of biochar in acid soil could increase soil pH and subsequently reduce soil acidity, attributing to the alkalinity of biochar. So this is data from the research that claim from this theory reduce soil acidity, attributing the alkalinity of biochar. Is it true? So we can see here the EFB biochar, rice husk biochar or palm kernel biochar. The range of pH alkaline. So meaning that with the characteristics of the biochar contribute the increase of the soil pH. So this is one of the research done by Songwei et al. 2020. So they compare between the liming and biochar. So you can see between the CK is control, this one liming, this one biochar. So you can see here when you apply your liming compared to biochar and control, you can see the result of the liming and the biochar is quite similar. Similar. That meaning that biochar can increase and similar, the capability is similar with the liming. So the biochar has potential to help to make it mitigate the soil aluminum toxicity and thereby improving the soil fertility, because soil pH is the main factors that for our crop growth. So you put biochar to your soil that can increase your soil pH, at the same time can improve your soil fertility, at the same time they increase your crop, your crop. Then another properties is we talking about the soil physical properties. So biochar application improve physical properties. For example, bulk density, porosity, hydraulic conductivity, aggregate stability, and moisture holding capacity. So this one, this picture show I share with you the how scientists sampling the soil bulk density. We use the coring. Then after that, we bring to the lab and we weight this coring. So before then we compare with the without by application of biochar and with the application of biochar. So soil bulk density decrease while water holding capacity and total porosity increase gradually with the increase in the biochar rate. So this is the biochar rate from this study from the 0 until the 20. So from the conclusion, you see the soil bulk density decrease when the biochar application 20%. And compared to 0%, so you can see the soil bulk density decrease and water holding capacity increase and total porosity increase. So this one, that means that in your soil, the porosity and the aggregate stability and moisture holding capacity increase with the decrease of your bulk density. So we're talking about soil physical properties when you apply biochar to your soil. Then we move after we know the function of the property of biochar, we know the physical of biochar. Then this one, the biochar can increase yield. When you apply the biochar to your soil, the biochar can increase yield. This is example. My student after apply biochar with the only fertilizer. This one is the recommended rate of the how to plant maize. Then we compare with the fertilizer plus biochar. So we can see here the increasing height of this maize. So when we see this graph, also compare the control fertilizer only. This one fertilizer only recommendation rates, and we compare with the application of biochar alone and rice husk alone, pumpkin shell alone, compared with the rice husk with the fertilizer. So when we compare between the fertilizer with the biochar alone, the result is significantly lower. But when we combine combination of the biochar and fertilizer, we can see the result is quite high, even similar with the fertilizer recommendation. So the conclusion, the application of biochar can increase your biomass and your yield. So this one is short term of the experiment shows that without biochar, without fertilizer, of course you can see the very low yield. Then we compare with the biochar and without nitrogen, and compare with the biochar and with the nitrogen is quite high. So compare this one, quite similar. Biochar with the very high nitrogen and with biochar and the less nitrogen. So we can see almost similar. That biochar with combination is quite good. Why? So we move. Why our yield increase when we apply biochar to our soil? This is the reason. Number one, when we're talking about the nitrate leaching, this is the very important part when we talking about when you apply fertilizer to your soil. We try our best to avoid our nutrient leach out to the groundwater system or run off to the surface area. So when we apply the biochar can help reduce the nitrate leaching from soil, because nitrates, this one we're talking about nitrogen cycle. Nitrates measure the amount of available nitrogen in the soil, because nitrates is a very critical process of the nitrogen cycle, which is the amount of available which is this stage the nitrogen is available for uptake for the plant that can be absorbed by the immediate by plants. It's available to plant. But when your soil is not fertile, for example, very sandy, so they can reach out to your water system. So we need to. So this is how to avoid this problem, nitrogen leaching. So we add biochar. So you compare with this graph with control biochar. When you apply only compost only, but when you compare between the biochar plus compost or biochar alone, so you can see the reduce of the nitrate leaching to the groundwater or runoff when you apply the biochar compared to the control and the compost. So this is a proof that this is attributed to the nitrate absorption and immobilization. So because the porosity size and the absorbent capacity of the biochar can absorb the nutrient and keep the nutrient, reduce the nitrate leaching. This is the one reason how our plant grow very well when you apply the biochar. So another benefit of when you apply the biochar is about nitrous oxide emission. This is about the problem our greenhouse gas emission, because nitrous oxide contribute 8% of the total global greenhouse gas emission. So agricultural source represent about 60% of anthropogenic. So agriculture activity contribute for the release gas nitrogen oxide emission to our air. So this graph shows, this study shows that when you compare between the normally that fertilizer that easy to volatile to the atmosphere, urea. This one example urea. So control plus urea and biochar plus urea. You can see the reduction of the nitrous oxide emission. So very low compared without biochar. So you can see the black color plus biochar. They compare with without biochar for another data here. So the biochar addition reduce nitrous oxide emission from soil, which is attribute to a decrease in nitrate source, improve and use efficiency and overall crop production. So when our nitrogen is keep in our soil, so we can use as a plant growth. This is the reason why our plant is grow very well when you apply our biochar. So another reason why our plant grow very well, because when we add biochar, has been shown to decrease ammonia volatilization and increase in nitrogen use efficiency. So this is a diagram quite complicated, but you can quite complicated. So but this one is biochar. This one is the reason why the biochar can reduce decrease the ammonia volatilization because of the pH effects. pH effect of the biochar, and because of the sorbent of the absorption and surface of the biochar, and because the capture on surface area of the urea in the biochar, and also because the soil microbiodiversity that the hole in the biochar that became the ammonia volatilization decreased. So this is the reason. So the conclusion about the nutrient retention, the function of the biochar for the retention from this diagram. So you can see just now I mentioned to you that biochar can reduce the fertilizer leaching. This one. So biochar can reduce the evaporation. Then meaning that the biochar hold the nutrient. So compared with the at the left is about the without biochar. So we can see the high water evaporation. So at the same high fertilizer leaching. But when we add biochar in your soil, at the same time maybe you add fertilizer, then you can hold your nutrient, then reduce the fertilizer leaching, reduce the water evaporation, then the fertilizer can be used for the plant uptake. So this is the example for an nitrogen dynamics. So on you can convert this dynamic to the phosphorus, calcium, and so on, because the concept of the transformation is similar, but for the phosphorus or calcium without the evaporation. So this one, the biochar application impact and transformation such as leaching and gases emission through the physical chemical absorption, biological immobilization. So we have microbe in our soil system that they absorb the biological activity quite high when you add biochar. So nitrification inhibition, so reduce fertilizer leaching. So they inhibit the nitrification changes in soil properties. So for example, just now we talking about soil properties, the basicity lower compare you without the biochar. So the changes of soil properties improve the uptake the fertilizer from the biochar. Then can release to the plant uptake. So this one about the benefit of the biochar for the nutrient retention and plant nutrient uptake. So another function where we relate about the biochar and soil health, biochar and soil carbon sequestration. So sustainable biochar system can be carbon negative by transforming the carbon in biomass into the stable carbon structures in biochar. So this diagram you can see here, anchar and the biochar. Anchar meaning the biomass you just put directly to the soil, and biochar, the biochar you can see the carbon remaining in the biochar is quite they can remain longer compare the carbon in the anchar. So this one is a nice diagram from the IBI, International Biochar Initiative, that you can get from their website about the comparison between the biochar and with only soil carbon. So this one soil carbon release to the soil carbon about this carbon cycle to our soil, and then carbon release 50%. But when you put biochar here and then release to the atmosphere 25%, because they keep remaining in our soil, because biochar can become one of the carbon stock. Biochar sequestration, carbon negative, reduce emission from the biomass. So this is the comparison between the with biochar and without biochar. Then another benefit of biochar related to the soil health is about biochar for the remediation of heavy metal contaminated soil. So we know that one of the factor that our soil degraded is about the soil pollution, because one example, because we using the over pesticide and so on. So biochar have received great attention recently for extraction of contaminant from contaminated soil because of their capability to retard the bioavailability of organic and inorganic pollutant. So this one I want to share with you about these diagrams, how the mechanism of the biochar with and without. So here is with biochar and here is without biochar. So this is one of the organic pollutant and metal ion, maybe cadmium, plumber, this one pH. That's one when you without biochar, this crop can uptake all the pollutant element directly to the plant. So you can see the M plus and this pH, so contain in our leaf or our crop and our yield. But when you add biochar, the organic or inorganic pollutant hold in our biochar, because the biochar can absorb the heavy metal or organic contaminant. So after that, when you grow our plant, so without the element of pollutant here. So you can see the comparison between the with the biochar and without biochar. So from this study, we have the proof that biochar can be the remediation of heavy metal contaminated soil. So this one also the one data that I would like to share with you, the removal efficiency of our biochar compared with without biochar. So you can see BO is 0 without biochar. When you compare with B2, B2 is with biochar. So the effectiveness or removal efficiency of the biochar quite high, even double compared to without biochar, 23% and 55%. So meaning that the biochar can be a remediate of heavy metal or contaminates pollutant, proven by our scientists for this one. Then another benefit of biochar, biochar as a catalyst, because this is example of the quite scientific. It's okay, I will explain with you. So this is an example about the ferrum, because ferrum is an abundant element in the earth and many, this one, then ferrum field remediation because the excellent reduction ability about the ferrum. When we combine the ferrum with the biochar, as a catalyst, make it more effective. So biochar has a large specific surface area and porosity and a rich functional group. So these properties not only provide support for ferrum, but also accelerate the absorption of pollutant. So this also we have another product, we call it ferrum. Usually we call it nano zero valent ion. Then we add biochar, make it more effective as a remediate. So the synergetic effect of biochar and ferrum promotes the physicochemical properties on the composite and its ability to remove contaminant. So for this, I will explain to you that you just put biochar, they also can remove the heavy metal, they can absorb the heavy metal, but at the same time, biochar also can be a part of the catalyst for the available products, which is the nano zero valent ion as a catalyst. So the function of biochar. So to make it available to remove the contaminant more. So another function of biochar is about the biochar is a carrier. Biochar is a carrier. Biochar as a inoculant carrier improve the soil function and crop productivity. So I would like to share. So nowadays we use the biofertilizer, PGPR, plant growth promoting roots are considered as a beneficial microorganism to be used as a biofertilizer. So, but when we use biofertilizer, they have the limited to our crop because sometimes goes to our atmosphere, not targeted plant that can get the PGPR. But if you combine the PGPR or the good biofertilizer with the biochar, then it can hold the biofertilizer for the plant growth. So the bacteria may be attached to the biochar particle in these several ways. So this is the method how the biochar keep in the hold in the the particle. So for example, by adsorption, by flocculation, by cross-linking, and this one is got the scientific term. But this is the various ways how the PGPR or the microbes can hold in our biochar. So biochar is housed and the bacteria is kept in the porosity, the area, the hole of the biochar. So this is example, the biochar with the hole, with the porosity. So we put the biochar, they keep together. So the example from my student works about the PKS only and strains of this biochar attached to the surface of PKS biochar. So you can see from the other SEM, scanning electron microscope. So this one diagram to share with you about that mechanism. The example, the tea leaf convert to biochar. So you inoculate that biochar with the biochar with the bacillus cereum. So we apply the biochar to the soil. So you can see here the biochar hold together for the plant uptakes. So this is the function of biochar as a carrier. Then another technology, because biochar also already good as a retention, good for the soil physical, but we can enhance this biochar. Just now I told you that biochar combination with the fertilizer is better crop growth. But this is the idea, another product. That means that biochar can be one of the encapsulated for the fertilizer and become a slow release fertilizer. For example, you put the urea in your soil, after 2 days and 3 days, the urea gone because of the voltation, leaching, and so on. But when you encapsulate biochar, your urea with the biochar, that become a slow release fertilizer for your soil. So this example, this one for example, hydrogen-based fertilizer. So you know one example is urea, for example. So we coated this biochar, coated this hydrogen-based fertilizer with the biochar. So we can see here the example. So the fertilizer hold longer as one of the slow release fertilizer in our soil for the plant growth. So they enhance our plant growth, water retention and nutrient uptake, and then reduce the leaching and volatilization. So this is one of the function of biochar as a encapsulated as a slow release fertilizer. So this is the diagram diagram about the non-char and with the biochar and PK. So non-char and the biochar. So biochar based fertilizer has been gaining much interest recently due to the biochar post slow release property and the release rate of nutrient of the encapsulated biochar based fertilizer depend on the formulation of encapsulating material. So we have a lot of the method how to encapsulate of the biochar. So it depends on the formulation, how the formulation. So this is one of the function of biochar and benefit of biochar to our soil as a slow release fertilizer. Then when we compare with the biochar and compost, compost also okay as a soil amendment, compost and other organic material in soil is valuable, but the minerals convert to the CO2 in just a few years. But when you convert of the organic waste into biochar, reduce the rate of decomposition, thereby enable the long-term storage of carbon in soil, leading to carbon sequestration. So this is the differentiate between the biochar and carbon, biochar and compost, and biochar is can keep as a carbon sequestration and also at the same time as a carbon storage. So this one is from the Professor Tim Lenton. Biochar has the potential to sequester almost 400 billion tons of carbon by 2100 and to lower atmospheric carbon dioxide concentration by 37 parts per million gases. So when we talk about the carbon dioxide concentration related to atmosphere, so this biochar can mitigate the carbon dioxide and then very closely related to global warming. So this one when we talk about the environment, so biochar is one of the products can help our environment to reduce to avoid and to mitigate global warming for the release of carbon dioxide to the air. Then this one another idea or another products that's nowadays quite famous. We're talking about co-composting with biochar. So for example, if you want to produce your compost, you add biochar as a mixture. So this one organic waste. So you have compost and you add organic waste plus biochar. So you co-composting with biochar. Co-composting. So these scientists call it combi or combi. So the combination of compost and biochar. So application proven from these scientists effect on soil fertility, plant growth, and carbon sequestration. Because when you co-composting of the compost and biochar promote microbial activity in compost. So at the same time dissolve organic carbon and in mature compost while increasing the fraction of stable humid materials. So the stable carbon in your compost and reduce environmental issue. For example, reduce toxic compound leachate and emission during the process of the composting. So this is another benefit of biochar for the production of compost, meaning that you co-composting, combine together compost and biochar during the composting production. So we go to the conclusion about the biochar and soil health with the list that I mentioned just now about the benefit of the biochar. Biochar contain most of the plant nutrient and the concentration of nutrient depend on the nature of the feedstock material and process condition. So this one it depend on your technology, and this one the conclusion. So biochar contain most of the plant nutrient and the concentration of nutrient depend on the nature of feedstock material and pyrolysis condition. Is your pyrolysis condition using the diesel energy and using the microwave technology? So maybe the product is quite different, varies compared the other compared with the other feedstock materials. Then biochar application improves some physical characteristics. Just now we see the bud density is lower compared to the without biochar, and at the same time increase the water holding capacity and the porosity. So biochar application increase soil pH, cation exchange capacity, also nutrient concentration. Of course, with the reduce of the leaching reduce the volatilization and reduce the gas emission of nitrate. So the concentration of the soil become higher. So biochar application decrease nutrient loss through the leaching and gases emission. Biochar application improve soil biological health, thereby increasing soil productivity. So the same time, the biochar, so for example, that soil already rich with the biodiversity, rich with the good bacteria. So you put biochar, that biochar can be carrier and can be a house for that bacteria, and thereby the increasing the soil productivity. Because the bacteria, for example, bacillus in Malaysia, in Universiti Malaya, we have Bacillus Malaya, one of the PGPR. For example, Bacillus Malaya keep hold in the biochar, then the plant will be uptake the PG that's Bacillus Malaya for the plant growth. So the biochar application improves soil health and crop quality. Of course, just now we talking about the remediation. Remediation, then meaning that the biochar can improve our soil health. So the biochar can improve the quality of the soil and at the same time the crop quality. Thus, it decreases the fertilizer requirement of the soil. So that I can conclude. Normally from the literature of the researcher suggested that we can reduce the application of the fertilizer when we combine with the biochar, because of the benefit of biochar can retain the nutrient in the soil. Therefore, the utilization of biochar decrease the fertilizer requirement of the soil. Then, if you want to know further about the biochar, so we have International Biochar Initiative (IBI), Biochar International Organization. So under this website, we can get a lot of information about the biochar initiative around the world. So when we talk about the Southeast Asian Asia, Malaysia, Myanmar, Philippines, Thailand, and also Indonesia, a part of the initiative, then you can go this website, you can click, they can know better about their activity and so on. So we already know this one is already actively using this biochar, aware about the benefit of biochar around the world. Then when we talk about the biochar in Malaysia, we have Biochar Malaysia Association. So I welcome you to be a part of the members of the Biochar Malaysia Association if you are the biochar practitioners. So you can Google about this Biochar Malaysia Association and get the form for the membership, and then you can join their activity. So for the outreach program, as mentioned by our moderator, I'm actively goes to our committee talking about the soil health. So we have a lot of the product to increase our soil. And for example, other than biochar, we have compost, vermicompost, and so on. So one of the product today we're talking about the biochar. So how I highlight to the community to use the biochar, because to transform or to produce biochar is quite costing, because they need energy. And so this is the innovation that produced by Universiti Malaya. That we transform this recycle kiln to the pyrolysis system, that you use the wood as a source of energy, fires, and we put the biomass here. Then after, depend on the feedstock, then for example, rice husk, within 2 hours you can get the biochar. So we are actively reach to the committee about the important to improve our soil and important of soil health. We are using biochar for the sustainable soil management. So this is one, the awareness in the television, also in the media, newspaper. Not only Malaysia, we also have then I found this article. Also we have another country, about Thailand also making the outreach program. So this one is Philippines, also carry out the program about the biochar as a base organic farming practices. And this one from the Vietnam, lead the way in the use of biochar building on an indigenous knowledge base. Then in the Thailand also, they also have the activity related to biochar, low technology biochar in Thailand, sustainable rural development and climate change mitigation. And just now we talk about the biochar can store the carbon. Then the same time biochar can increase and improve the soil properties. Then this is the technology how the Thailand outreach their committee. Then also Indonesia, they also have the Indonesian Biochar Association, our Southeast Asia countries members. So they also provide the workshop how to promote the biochar in Indonesia. So at the end my slide presentation, we're talking about the soil. This is one is quite famous quote by the former president of US. A nation that destroys its soil destroys itself. So the nation is, we're not talking about the country, we're talking about the committee, about the personnel, about the anyone that destroy yourself, your soil. So meaning that you destroy yourself, because soil is very important as a foundation for the crop production, foundation for the human needs, for the foods. So a nation that destroy its soil destroy itself. Then another quote that my last presentation. We do not inherit the earth from our ancestors, we borrow it from our children. So meaning that our soil, our earth, we do not inherit from our grandfather or mother. Actually, we borrow it from our children. So hopefully, whatever we get the soil or the environment. So we need to return to our children as similar or maybe better to our children. So this quote is very good. So we do not inherit the earth, but we borrow it from our children. So that's all, moderator, about my talk about the biochar. It's about the benefit, how the production of biochar, and about the activity in the Southeast Asia. So biochar is black, is the new green. Also, some farmers call it biochar the new black gold. Thank you.
Okay, thank you, Dr. Rosazlin. Okay, now we already have a few questions. Actually, we received a lot of questions, but due to time constraint, we're gonna select about 10 questions to be answered by the rest of the question will be answered by email. Or if you have another questions, you can email to the address in the chat box later. Okay. All right. Okay. For question number 1, in your presentation indicated that biochar have liming effects. Is biochar alone sufficient? If so, what is the suitable rates to be applied?
Okay, thank you for the question. Yes, according to my presentation, yes, biochar can be biochar has liming effects by reducing the pH of the amendment of the soil. So when we talk about the biochar, is it sufficient to apply alone? So just now I share with you the one graph that mentioned the biochar. Actually, when you compare with the fertilizer and biochar alone, the result is some studies shows the result is quite similar, and some studies shows the biochar is low compared to the fertilizer. So normally the scientists suggested to the farmers to apply biochar in combination with the chemical fertilizer, because biochar is not fertilizer, biochar is soil amendment. So for the rate of application, so when we need to consider about the economical, for example, cost of the production of biochar, transportation, for the labor charge. So the recommendation is less than 20 ton per hectare, and 10 ton per hectare is quite a good number actually. So my suggestion is 10 ton per hectare and more less than 20 ton per hectare.
Okay, for the second question by Mr. Ang, he asked about can biochar properties further enhanced?
So when we talk about the biochar properties, normally we're talking about we highlight about the size of porosity of the biochar. So currently another technology that we conducted by our researcher is we enhance the biochar properties by activate the biochar. So we call it biochar biochar activity carbon. So we have two methods, which is the physical or chemical activation of that biochar that can improve the pore size and also surface absorption properties. So we call it the activated carbon. So we can enhance. We call it then the method by physical or by chemical. So the answer, yes, we can enhance the biochar properties by activate the carbon.
Okay, for the third question by Mr. Tan, how to determine how to determine the quality of biochar?
Actually, to determine the quality of biochar, because the quite expensive, because we need to using the high-end instrumentation. For example, to check the porosity, you need to use SEM, scanning electron microscope, to know the porosity size, and also we need to analyze the physical chemical and so on. So for instance, you just if after you get the biochar, you can test with the that I share with you, the very simple experiment with without with the pot, and then you can see the growth performance. Then you can check the quality. You can check the quality of the biochar by the performance of the crop. But if you have budget, you can send your sample to the lab, and then and at the same time, you should know to the function, why you want to, what the purpose you need for that biochar. Is it you want to enhance the soil pH? Is it you want to enhance the nutrient retention? Is it you want to enhance the soil physical properties? So you need to find the specific biomass. Then automatically from the previous study, you can read from the initiative Biochar International Biochar Initiative, a lot of articles that you can choose directly that waste as your purposely what you want to use that biochar. That is the answer. First, how to know the quality of biochar? You need to run the test for the physical chemical analysis, or you can make it the small experiment by yourself, or to read then maybe you can choose the specific biomass by the previous record done by our farmers or researchers.
Okay. The next question, Doctor. In your opinion, what is the future outlook of biochar amongst our local growers?
So, okay, when we're talking about the outlook or about the practices of the biochar among the local community, because I always already done the transfer knowledge to the community. Normally, when we ask the farmers about the biochar, normally the majority of them do not know about the biochar. But when we highlight to them about the benefit of biochar, so they realize that the accepting of the using that biochar is very high, and they're keen to use that biochar. So hopefully with the, for example, today activity and also a lot of the awareness and outreach programs, so our growers can open their mind to use a biochar as one of the product for their soil.
Right, Doctor. Okay, the fifth question from Mr. Tan. If the soil is ex-mining with high sandy compositions, does it suitable to add biochar to alleviate soil fertility?
So when we're talking about the ex-mining is normally one of the problematic soil in Malaysia, because ex-mining, the texture is quite sandy, of course. and then the same times as mining, the concentration of heavy metals is quite high. So it refer to the benefit of biochar. Biochar can improve the soil properties. Biochar can remediate the heavy metals. So yes, of course, biochar is one of the products that can help to elevate the soil fertility of the mining area. So I encourage you to use this product if your surrounding area is ex-mining area, because normally ex-mining area is quite high heavy metals and then not safety for your crops. So biochar is one of the solution because they can absorb the heavy metals, then make it your plants safe to eat.
All right. Next question. It's a favorite question. A lot of people ask this question. How does biochar ensure better nutrient use efficiency for nitrogen?
So how does biochar ensure? So how does, of course, you can, for example, if before this you not use biochar for your crop, then after that you use your biochar, after next crop you use biochar. You can see the differentiate between the growth performance. So this is one of the indicator how you ensure the better nutrient use efficiency with the comparing between the with and without. This is one. So the behind of the mechanism, of course, due to the volatilization reduction, due to the leaching nutrient to the water system, also the biochar can increase the water holding capacity. So how to ensure? You need to see the growth of your plants. If your plants grow well, of course, mean that the biochar help to attract or hold your the nutrient.
Okay, thanks. Okay, next question from Mr. Romeo. Okay, which method is suitable to make SRF using biochar?
Oh, okay. Biochar can be a slow release fertilizer. Biochar is not fertilizer. Biochar is soil amendment, but they can be a slow release fertilizer when you encapsulate the fertilizer with the biochar. Then when you want to coat it or you want to encapsulate the biochar, you need to use the high end, or you will need to use the machine. So this one is even small which scale quite. So I'm not sure if you want to use it at home. It's quite costing this machine, and even though you need to optimize the encapsulation of the biochar and the fertilizer. So this one it require professional maintenance about this. This one is more we talking about the industry level. So is it possible? Yes, I think not recommend you use it at home. So we use for the industry level that need the professional authority to produce this product. Another question?
Okay, sorry. Next question is, how long has the study of biochar in Malaysia since it was first commenced?
Oh, okay. I actively involved in the biochar work since 2013, but as my knowledge, biochar in Malaysia already began in the early 2000, and even though we have Biochar Malaysia Association since 2010. So I would like to say it's almost 2 decades. Yes, the biochar in our country. So a lot of institution or agency involved in the biochar works, and farmers also already involved. So that's what the question is about, when the Malaysian started this biochar since 2 decades and actively early 2010, if I'm not mistaken.
Okay. Next question is, what is the difference between biochar and normal charcoal?
Oh, so when we talk about the biochar, when you tell the people about biochar, already in your mindset is about biochar is a soil amendment automatically. But when you talk about the charcoal, so people not relate usually not relate the charcoal with the soil amendment. Usually charcoal we relate to the fuel as a barbecue and heating or cooking. So this is the main differentiate between the biochar and normal charcoal, because charcoal purposely the production for the use for the fuel and barbecue and heating and cooking. But biochar memang purposely for the soil amendment. And generally charcoal generally contain lower ash content, higher than biochar is quite high. Unlike biochar, charcoal generally contain the lower ash. But the main answer about the how to differentiate, biochar purposely when you want to make it the biochar is for the soil amendment, and the normal charcoal is for the fuel and barbecue. So they have another function. So we don't see the charcoal for the soil. No.
Right.
I think to produce charcoal quite costing, Tuan Hairul, compared to biochar.
All right, thanks. Okay, last questions. What are the differences between the existing biochar production technologies?
So the existing biochar production technology quite good nowadays. So we have a lot of the company or industry already set up their company to produce biochar. Compared previously with the earlier 2010, we still in the innovation stage. So so different between the existing biochar production technology, of course, as I mentioned before this about the technologies they use in terms of the temperature and the residence time. So and also the source of energy. So this is depend on the industry, the best of the technology that you want to use. But the various biochar production is due to the temperature and due to the temperature and due to the time and due to the process. Is it fast pyrolysis? Is it the slow pyrolysis and so on? So the technology also depend on the feedstock of the biochar.
Okay, thank you, Doc. Doc, anything? Is there anything else you would like to mention?
So I think okay. I would like to say thank you again to the Behn Meyer because inviting me as a guest speaker. So I would like to welcome to all participants, and together we promote wise use of our soil resources, and one of the method how to mitigate, how to conserve our soil using biochar. Because just now I will for my conclusion, a lot of list of the benefit of biochar. So we are at the same time stay safe and stay healthy. So I hope that we can adapt the new life about our current pandemic nowadays. So, okay.
Okay, thank you, Doc. Okay, for the participant, for your information, today's presentation will be uploaded to the Facebook Club Petani Behn Meyer. To anyone who has not yet joined our FB group, you may join this group. There's a lot of information related to soil health, as well as related Behn Meyer AgriCare products such as Deep Soil and Aroma. Okay, lastly, I would like, on behalf of Behn Meyer AgriCare, again, thanks everybody for joining us in today's session. We hope you all find this seminar highly engaging, fruitful, and beneficial. We are extremely hopeful that this seminar is also going to be a great success and appreciate your support. Hope we will see you again in the next webinar series in the near future. With that, thank you, and remember, stay safe. Okay, bye-bye.